Today we will go over vector components invariants. We all know that basis vectors transform given the following transformation. And that's just expanding it in the multivariable chain rule. And to find how vector components transform when your basis changes, we do the same thing. Here is the j over d lambda vector component, and we simply expand it in the multivariable chain rule. So this should be dcj and dpj instead. And then dci over d lambda. So as we can see, to transform from the old basis to the new basis, we multiply it by this term. And we can see that these two terms are reciprocals of each other. Or in other words, ci over pj times cpj over ci will give us the Kronecker delta ij. Actually, it wouldn't give us the Kronecker delta. It always gives us 1. They are the reciprocals of each other. And this implies that when our basis grows, our vector components will shrink. Or if our basis grows by a factor of 2, your vector components will grow by a factor of 1/2, or shrink by a factor of 2. And we also know that we can write, like, one way of writing the transformation is, the basis vector transformation is like this. Here's one way. It's just the multivariable chain rule in the Einstein notation. We can also write the transformation as a matrix, the Jacobian matrix. So here's the Jacobian matrix. Here's like C1 over P1, C2 over P1, something like that. You basically have these components in the Jacobian. It's like partial x over partial p, partial y over partial p, partial p over partial x, partial p over partial y. Oh yeah, I got partial x over partial r, and then partial y over partial r. And instead, that this would be like, in this form, it's C1 over P1, C2 over P2. These are both P2s. This is C1 and C2 respectively. And here we have partial R over partial C1 and partial R over partial C2. And when you multiply it by this matrix, you get partial R over partial P1 and partial R over P2. You have this Jacobian matrix, and you multiply it by your old basis to get your new basis. We already know this. This is just review. So for vector components, we would instead take the components, which is like partial C I partial C1 over D lambda partial C2. Sorry, dC2 over D lambda. We would instead multiply it by the inverse. I'm not going to write out what the inverse would look like, but you should already know how to get the inverse. We multiply it by the inverse of the Jacobian matrix, the inverse matrix, and then it would spit out dP1 over D lambda and dP2 over D lambda. So that's how you transform your components. Just use the inverse Jacobian or just expand it in the multivariable chain rule, and you should get your components in your new basis. So yeah, that's how you do it. Thanks for watching. Have a good day.